Hey gang, newsflash, Wi-Fi is critical. This is the most obvious thing, obviously, ever to be able to say, but the reality is there's a lot of potential damage that can happen to our Wi-Fi signal. We don't live in isolated lanes. And so when we try and consider how to get the best performance out of our Wi-Fi, then, well, what are we fighting against? Really, that's what I want to know. What's out there? Well, some parts of what's out there are simply other access points. And one of the things that we can do is observe access points that are around us, what channels they're on, and make adjustments. And of course, we talk about RF groups and some of the signaling tools that are used there. Another tool that's a part of the Cisco arsenal that can be used to detect Wi-Fi signal, but also non-Wi-Fi signals of interference for a particular access point, such as Bluetooth, analog video, maybe various different types of wireless monitors that might be used, even microwave ovens that might overlap. We can observe that through what's called Cisco CleanAir. Right? Cisco CleanAir technology allows the access points that are in my network to be able to gather information, forward it to a wireless LAN controller, which then can potentially forward it to other sources of it, other management tools like Mobility Services Engine or Prime Infrastructure. And I can essentially paint a map of what's going on in my network and start looking to how I can manage the access points that are dealing with that noise or how to actually manage the noise itself. So we're trying to control not just Wi-Fi signal interference, but non-Wi-Fi sources of interference, okay, specifically. So some key terms that we're going to recognize. Spectrum intelligence is what we're gathering. We're going to evaluate sources and give them a severity index number. We'll give our access points an air quality index number to say how good our access point's doing. Each device is going to have an interferences device report to relate to that device. And some devices, which, for example, like let's say the difference between a Wi-Fi signal, its interference versus a an analog video signal is analog video doesn't have a MAC address associated with it. It's not digital. So we'll generate pseudo MACs, put those into those interference devices report, and as necessary, merge those IDRs on multiple that are coming from multiple access points. We'll talk about those here in a bit. Gang, part of what's awesome about this is, again, the information is gathered from one or more access points, converged and merged on one or more wireless LAN controllers, and then we can send that information out to Mobility Services Engine and or to our prime infrastructure environments. And we can actually paint maps of, okay, literally, here's what our network looks like. And, out there we've got this, evil box number 9 that is sending out some sort of signal that overlaps with my world. And so prime infrastructure will let us see that, and it'll actually show us here's the zone of impact. In other words, here's the access points that are hearing that are affected by that source of interference that might be, analog video, microwave oven, monitors, all sorts of things. Our access points themselves can run in a couple of different modes. They can run in local mode or monitor mode. A local mode access point is just an access point, serving clients, acting like an access point should do. But what it will do is send its information about clean air to its wireless LAN controller. Okay, so that's cool. So if it supports the CleanAir technology or CleanAir Express, then it can send that information up and that can be managed. A monitor mode access point will actually not be serving clients. Instead, it's observing all bands, right? Not just the bands it's serving, but all bands, and gathering the most information about what's going on with potential sources of interference. So local mode serving clients actually can come to convergence very quickly because we've already got neighbor messages going back and forth. It's very efficient that way. But monitor mode gives us a bigger band of observation from one or more devices, right? That we assign that mode. Finally, last bit of information here. If you see the term adjacent, overlapping or adjacent off-channel interference, right? Overlapping or off-channel interference. All it's saying is I've got some Wi-Fi signal coming in as interference, and it's from some access point that's out there, but I'm on channel 6, and this interference is off-channel. It's coming from channel 5, let's say in the 2.4 gigahertz range. So I'm hearing it, but it's not actually in my channel. And so it's a way to help relate to sources of interference that are parallel but not lined up straight with the channel you're on.